Awesome. Okay. So I got your notes.
Thank you. Okay, so Emily will be our note taker for the session. Thank you, Emily. You are awesome. We have a big agenda for js-ipfs today. I hope that you all have the other pad open. It will be mostly talking about what we are going to do this week. Talk a little bit about like what we can improve in our development process for js-ipfs, and like go after the milestones that we already have set and review them and like describe the current status of each of them. So cool. So plan for this week, and like something that I wrote in an issue somewhere is that it will be very important to take the opportunity that we are all together, and like since we are going to review all of our goals for js-ipfs, to also write down comprehensive lists of the things that have to happen for each of those endeavors. So far, we have been developing js-ipfs on a milestone base that are ordered, and like we are been focusing in one after the other sequentially. But there is a lot of things that now, especially as js-ipfs evolved, that are unblocked, that can be done in parallel, and that necessarily don't depend on anything to get started. So there will be several sessions this week, and what I hope to take from each session when the session ends is a list of things, or at least like even if it's like just very like just words of the things that need to happen in order to conclude that endeavor. Can be from files and MFS, can be like completing bitswap, can be DHT, can be the relay, can be whatever pops up, etc. But like having this list of tasks that then we can like curate, polish, and publish in the js-ipfs repo, so that other people can come in and see, oh, like here's this endeavor, here's a list of tasks that need to be done. I know how to help. I will help with this, and I know that the team is being focused on another endeavors, and this one is like more free to get help on. We actually, when we started developing js-ipfs last year, this is something that we did, and we did it based on command. Right now, since we have more things built, and like commands are not like the first level interface to js-ipfs anymore. Actually, you are talking about the real component inside js-ipfs. It makes more sense to talk about the real components of js-ipfs. So cool. This is my hopes, and I know we can do it. And again, it doesn't have to be like super clean after each meeting. It just has to be something, and then I volunteer myself to polish those lists and publish them to js-ipfs repo. Cool. Next up, does everyone agree? Get a thumbs up, people. Sweet. Cool. Next up in js-ipfs development process is we have been like we can improve the way that we develop js-ipfs if we focus on getting user feedback. So right now we have been developing js-ipfs by our own intuition and by knowing what's right to be next. But more and more there are people that are trying to use js-ipfs and js-ipfs API, and they have specific needs. There's some lines that like go-ipfs does it. There is like a core structure of the development that like needs to be layered, but there's a lot of people coming with needs, and then typically makes like shifts the priorities for the developers of the project. And we need to incorporate something like that into js-ipfs. We also don't have a release cycle, which I think it's like a very poor management decision for a project that people need to rely on. Like we should be releasing like every 2 weeks or every 3 weeks, and making sure that we communicate to our users what was released, what was developed, so that we can get quick feedback, and then we can shift our priorities based on that feedback. For example, we just talked on Orbit that like now to get Orbit loading on a web page, we need PubSub and we need Relay. Like Relay just bumps up to the priority because we now know that we have an app that needs this feature in. It's more important than other things. And I'm sure there will be other things that will source from the community that they will tell us that they need on js-ipfs, so that they can use js-ipfs for the apps. One of the things that we keep hearing is documentation. People want to be able, this is almost ridiculous, but people want to be able to add files and like, get files from IPFS using js-ipfs and js-ipfs API. And although we have been doing a lot of effort in like standardizing interfaces and like creating specs, and which are pretty great and like make sure that like our implementations follow those interfaces, they are not that clear. We still don't have like good tutorials, so we still don't have examples. And we get a lot of this feedback from IRC, from email, from GitHub issues, and even in person. Like, I remember really well, like being in DEF CON and people telling me, I just want to like to add some JSON and get some JSON for IPFS. Tell me how to do it. I'm like, oh, I'm so sorry. I didn't know it needed to be so frustrating. So, yeah. Focusing on the development process and make it look like a product, something that we are shipping to our clients, our users, will make us move faster, will give us a sense of urgency in certain features. It literally painstaking. I get a little bit sad, but then I get motivated to fix things. So it's good. So cool. All right. Does it sound good? Awesome. Go ahead.
So to reiterate, you're saying that the top big things are improving the feedback loop process, having a reliable release schedule for what we're doing, and then improving documentation across all areas. Okay.
Yeah, those are things that we already know that will be very important. Juan?
Are those the three most important things for the entire quarter, or are there other like?
No, this would be like the laying the ground so that we can develop the things in the quarter. This is just like, hey, we should not take a lot of time to say, let's release something every 2 weeks and like communicate with our users that something was released and a new feature is in, and ask them to tell us if stuff broke for them or if they are happy with the interface and so on. Like that should be something that requires minimal effort, but like just requires us to change our mindset of how do we develop js-ipfs. Cool. So now let's jump into the things that we need to focus this quarter and that we will understand during this week if we have time to all of them, or which should be the ones that will come in front and the ones that we, again, can have these lists of the tasks for each endeavor, and then we can get some help from the community. Taking first from the things that we worked on Q3 and that they are still a work in progress. Some of them are really close to be finished, but nevertheless they need to be complete. So one of the things that we worked on Q3, although it was a milestone 4 issue, we got a lot of work done onto that front, which is the sync crypto. So sync crypto means using the web crypto API on the browser and the crypto Node.js module on Node. This means that like we are using now native bindings to crypto libraries that run way faster than the implementations in JavaScript that we were using before. If you have used js-ipfs in the past, you might have noticed that like generating keys is like a pain in the ass because it just like takes forever. If you looked at benchmarks, you would see that like Psych.io takes 80% of the time from like exchanging a block. And with this usage of native crypto libraries, we can reduce those times vastly. This does mean a big change though, like as the title says, async crypto. So we are not, because the web crypto API in the browser only knows how to do async crypto operations, again, just so it doesn't block the event loop, so it doesn't block the UI. It means that like we now have to cope with the sync calls everywhere we do crypto across the project. So that's like a big PR with a lot of smaller PRs across several repos that they are already out there. Friedel did like amazing work like going through all of those. They already were reviewed. We are like polishing last things and making sure that we communicate that very well and that we don't break anything. But the PRs are there, so expect that to be very, very soon. Go ahead, Friedel.
Just one note that you didn't mention. Big bonus of using web crypto in the browser for things that are available is great reduction in file size. The current builds, just to give you an understanding of how small we're getting, is We are now looking at 1.2 megs minified JavaScript for the whole of js-ipfs. I think at the beginning of this year, we were looking with less features at over 3 megs. So this is pretty good.
That's very cool. Yeah, like I think it was actually 4 megs. So we already shipped 3 megs from like the bundle. Small note when you're speaking, that it could be closer to the laptop because you're using the laptop's microphone. So it's kind of hard to hear. Cool. So yeah, and that was like one of the things that like a lot of our users were requesting, that we reduce the bundle size so that their apps don't take forever to load. Cool. Next up, testing infrastructure. So we added a ton of tests during last quarter. We really made things more robust. We detected a lot of errors in js-ipfs just by writing the same test or running the same tests over the API and through core using the interface ipfs core. But we still have things that we can improve there. One of the things like Chris Cole has been working on is like bringing the shardness tests to js-ipfs. We already have a PR that has that set up, so we can now run shardness tests over js-ipfs. And what we decided was to have this set up first, and then like have separate PRs for each command, and then like basically tackle each of the commands one by one and see what breaks, and like fix each of the commands, which then will fix issues on js-ipfs separately in parallel. A lot of the commands break because like we don't support every option. For example, js-ipfs version doesn't have the --all option. So those are not really like protocol implementation problems. It's just like things that we have to like just spend time making sure that like it's CLI feature complete, so that all the shardness tests pass. So yeah, we did progress there. We started. A lot more will be done next quarter. Interoperability tests are always like one of those that we keep talking about, and they're really important, but because they kind of consume time and like we kind of get distracted by all the other things, we never really like set our minds to do it. And as was reiterated several times across like several other sprint meetings, it's about like how can we do interoperability tests with versions that are on master of GoIPFS and not like released. So we need like to have a way to build GoIPFS inside our CI system, or we just like test js-ipfs against the released version of GoIPFS, which it will be something more natural, maybe like 1 quarter from now when things are more and more stable, and like we don't have things to change, for example, in the network stack, which is right now the problem where like the speedy version that's on the release version of GoIPFS doesn't really work with js-ipfs. 2 things that can be done in the front is like using ipfs DCTL, so like using the release version. The other thing that we now are getting through the shardness tests is using through IPTB. So IPTB, the interplanetary testbed that Jeremy built to test GoIPFS, can run as long as like a binary uses the same CLI interface. It can run any node, and because it can run any node, can like spawn any node. So with the shardness tests and like with the refinement of the CLI interface for js-ipfs, we get a way to use IPTB to run the same tests that GoIPFS is now running. It's pretty cool. So we can like port all of those over, or just like run them in parallel, and get all of that interop testing for free by like spawning some js-ipfs nodes into the mix of GoIPFS nodes. This is something that like again, it was one of our quarter 3 goals, but a little or no time was put into, and it's something that's really important for us to like be sane and sleep at night, because we want to make sure people like can use js-ipfs and GoIPFS without having to think that there is quirks. So really important for Q4, I would say. And there is benchmarks. So one of the sessions that we should have this week is about benchmarking and performance, network profiling, memory profiling, etc. We right now have some benchmarks. It's on a pull request. It's the benchmarks that we ported from GoIPFS. We need to merge them. So it's like one of dangling PR that's there that we need to click the green button. All right. Next up, like, so if I'll just go through things because the list is so big, like, just interrupt me if you have something to say. Fixed bit swap implementation. So we learned a couple of weeks ago, well, maybe 1 month now, that our bit swap implementation in JS is not to the same level as the ipfs one. It has some problems, namely when transferring large files or a large set of the directories. Fixes were done towards that, towards getting that implementation good. More fixes have to be done. This is probably from all of the things that are missing on Q3, the one that we don't have a necessarily like time estimate of how much time it will take us to like finish it. But we do know that like if we review it on this week and like we come down with a list, especially of tests, like robustness tests, like making sure that we know how to identify the problem and make sure it doesn't appear again in the future, we can compile this list of things that we need to do in order to get BitSwap really good. And then we can like spend time finding and understanding what is the problem. Frido, you want to add something?
Yeah, I just want to add just very quickly to this issue. It's currently not clear that this bug is actually part of directly BitSwap implementation in JS. It might be a bug in the network communications because for some reason, at some point, the communication stops. And it's not, I've spent, I think, 2 days or so around this code debugging it. I did some things were fixed, not everything. It seems somewhere is going something wrong, and this might be in network code or in BitSwap. So BitSwap is just where we see it failing. And the test is very simple. It's actually just, I used Orbit. Orbit is a very good example, the package Orbit app. Try to share that from one IPFS to the other IPFS node. And if that works, you can be pretty sure that the basics are working or not working in this case.
Another way to test it is just like connecting a js-ipfs node to another IPFS node and transfer a large file or like a significant size file. It doesn't have to be like terabytes or something. Cool. Yeah. Next up, js-ipfs API. So we have a bug on js-ipfs API when doing get. So get So one of the things that like actually is weird on the HTTP API level is that like to add files we use multi-part messages, to get files we use tar stream, and get uses the tar stream and the Node.js module that we use for the tar stream as a specific way of working, which makes sense when you think about tar, which is like you can only read the next file once you finish reading the first file. So like to get to the last file, we have to read through all of them. And like read through all of them, I mean, not just understand that there's a file there, but actually drain that stream of that file. And this is done because like it's a way to avoid like having a module, the tar stream module, just overloading the memory of the process. So in some way, it's understandable why it is built that way. Our assumption and what we had done in js-ipfs to the get core API was that like we just emit streams with readable streams for all the files. So our interface IPFS core tests were done for something that could emit readable streams for all the files. Because since like everything has backpressure from disk, it will make sense. So like when you put network on the middle and then you put a tar stream on the middle, things act differently. So now we have a PR that fixes this on js-ipfs API. And that changes also interface IPFS core tests to stop this assumption that we can get the readable streams for all of the files that come in the tar stream to just like have stream by stream, one after another. Again, PR that's there needs to get a seal of approval and merged and good to go. Cool. The other thing is the RLU cache. So something that we learned during DEF CON is that we could save a lot of time. We cannot save a lot of ops, a lot of operations, and a lot of time in orbit if we have a simple cache on the get request for the object, something that was not there. So would mean like if you did a get for the same hash, you would be really like doing an HTTP request to the node. Like that's just like super expensive. So we now have a PR that adds a simple URL cache to the get. There is more things that we can do there to make it even better. The PR is there. I'm not remembering exactly what are the other things, but yeah, the URL cache is there. It works. Orbit uses URL cache today, and like it saves a lot of time on all the operation areas. So yeah, one more PR that needs still improving. Cool. Interface IPFS score. As I said, like we did. Hey, Kuma is here. Cool.
Just so you have 6 minutes.
I only have 6 minutes left. Oh,
Just don't talk faster. Talk smarter.
okay. So interface IPFS score, we did a lot. We have a lot of more tests. We have the spec written down for GHT and name. We have already the tests for GHT. They need to be refactored to follow the same pattern that we do all the other tests. And then we need to like do the test for name in the same way that we did the test for all of them and merge those. Cool. Awesome 3, IPLD. IPLD, it was like one of the big goals of Q3. We got a lot done in terms of like really discussing and nailing down interfaces and how to integrate everything. We now have this like set of PR. Like Jeremy has been working a lot on IPLD for Go, which has a set of extra challenges of how to support multiple formats on the same resolver because of types. In JavaScript, fortunately or unfortunately, actually this gets a little bit easier for us because we can just deal with having no types and just like have our resolvers be completely agnostic to types. And we have the PR called Awesome IPLD. I thought, like, for lack of a better name, I thought it was awesome, so I called it that. And yeah, basically we finally figured out how to support multiple Merkle DAG formats on the same resolver by plugging it in with the custom resolvers for each format. It is pretty cool, pretty excited. We are working right now, like we already have the protobufs there. We are like finishing the CBOR stuff, and we are working on getting the Ethereum blocks to be resolved through the same resolver. Yeah, and this is like one of the big focuses definitely for Q4. I would even say for the next weeks because a lot of people want to use this. And we also want to get this done as soon as possible because we don't want to deal more with all of the formats. Cool. So milestone 4, developer experience. Okay, I'll go through all of these major points at once. We want people to not feel the pain of like having to understand and read code to like use js-ipfs and js-ipfs API. This will fall really well to the idea of like release cycles. We need to level up our documentation. We need to figure out a way to create a page of documentation for all of our modules. Right now, it's kind of like cumbersome that you have like to dig through like all the modules to find like API docs. It would be like sweet to have just a page that people can say, oh, this work, and like just find the API call and understand what data it takes and like what it returns, and like have an example. Examples are really important, more even than like sometimes interface like function signatures. Yeah, and then there's like building and bundling. A lot of work was done this quarter, but like we just want to like do what we can, like invest the time to do the things that we can reduce the bundle by the most. Like we already shaved from 4 megs to 1 meg, and we can even do more. And yeah, milestone 5, routing. That is the IPFS THT. It is one of the missing pieces to get the JavaScript implementation par with Go IPFS so that I can find any node and connect to any node. Of course, it is not the only thing. Like again, without relay, browser nodes will not be able to connect to the rest of the network by themselves. But yeah, like we have settled on building the IPFS DHT in the same way that Go has, and then building the next version or bringing back the next version that was done first in JS, which is the peer routing separated from the content routing, so that we have multiple record source. Milestone 6, feature parity. This was a milestone that was created the last quarter as like the rest of things, like the bag with the rest of the tasks that we need to do. This will, I feel, or I believe that this will be broke into several milestones, namely like Unix-FS engine and MFS. So getting all of the tart importer, getting charting working, getting MFS. One of the things that excites a lot of people is being able to have things like registry mirror, like NPM on IPFS, running solely on JavaScript, so that they can install everything as JS to NPM or even as a browser tab. Like imagine like loading a web page, a Nash, that is the full bridge to the NPM on IPFS, and then like having your NPM CLI being able to connect to that browser tab and then downloading modules from that. Like again, basically doing stuff with IPFS without installing anything. It's always like the dream. Cool. Ping is here as like milestone 6. Francisco, which is not here, he has been working on that. It is on PRs that need to be merged. We can get that done pretty soon. It is a simple thing to add. And then there is IPNS, which is a very important piece, and a lot of people have requested it. Not sure if there's a lot of use cases right now, but at least people want to understand how they can do the naming on js-ipfs as well. So again, we'll break that into a separate milestone with specifically stuff tasks. And I'm 1 o'clock. Woo! Thank you all. Thank you.